Hi, good morning, and welcome to the ZP. Hi, welcome to the ZP Developer Zone webinar. So we like to do this sometimes a couple of times a week, and it's really just about technical questions that come in during the week. So I won't spend a lot of time. I'll just jump straight into it and say today is approximately 8 a.m. 25th of January, and I say here 2023, but I realize it's 2024, so I can correct that. That said, let me go forward. I say approximately because it's actually 7:15, but plenty of meetings today, so we do need to go nice and early. A lot of what we do these days is actually focused around our Sensi All platform. Now, when you're developing products, it is easier to do what I think of sometimes as IVD or spot testing, where you take a sample, you put it on a sensor, you get a result, and the sensor is disposed of. It's all over within a 2-minute period, and essentially a lot of problems go away in that form factor. Now, admittedly, today we're actually going to talk more about wearables and continuous monitoring. But I just want to say that if you're interested in the ZP stack of technologies in general, then I would actually suggest coming to one of our webinars, and we're going to have one on the 27th of February. We do one in the morning and we do one in the afternoon. And the only reason I bring it up a little bit is because, you can attend that. So, and if you see a link here, I'll put the link underneath the video as well. It's also worth saying that one of the people who's inquiring today did want to come to one of our workshops in the UK. I did suggest that if you can get enough people together, we can also do the workshop on their site, but that's if they can get enough people together. So we do corporate workshops, where we go on site. First of all, we do workshops, especially on wearables and things like CGM, actually at our site. So we're doing a 2-day workshop in Norway, and I'll put a link to that. The CGM is particularly relevant today because continuous glucose monitoring is the kind of leading light, let's say, in continuous biosensors. And so I have 23 years experience in glucose monitoring. And it's not just glucose monitoring. You'll see at ZP, there's a whole list of analytes that we're interested in, but I do have quite a lot of experience in glucose. But that then translates into continuous glucose monitoring as well. So we do have a workshop on that in March in Norway. That's pretty good. And then we also have these, we go on site and do workshops as well. So I have been on site to companies, giving these workshops. If you want to kind of have ZP come on site and really dig into some of this technology, then have to put together enough people that it actually makes obviously financial sense for ZP to come on site as well. But that said, I'll put the links underneath the video as well. We're also having a workshop in the UK in June 2024 about commercialization of electrochemical biosensors as well. So I'll put a link here as well. So the questions today one is about wearable sensors for fatigue. So you'll see the questions, but it's really around about sort of looking at the wellness of people working for 8-hour periods and how we can monitor that. And then a discussion number 2 is Gen 1, Gen 2 and Gen 3 glucose sensors. These two questions, they're not the same question. They're kind of related. One of them is really about application. One of them is really about the core technology. So I think it's sometimes interesting to talk about application, but in question 2, we will talk about the core technologies as well. That said, let me go forward a little bit. This is with question 1. So at ZP, this is an example here. This is a watch, and this is actually the sensor. I'll probably talk about this in a little bit more. And the sensor actually plugged into the backside of the watch. I've got some slides on this in a minute. To get to this point, this has had 20 million euros spent on it. So this is why I'm a little bit reluctant on some of these questions, because this is technology that ZP owns, by the way, but it's such an expensive effort, and we are looking for partners, but these partners are really well funded on this kind of work. Anyway, they want to measure cortisol, lactate, pH, sodium, potassium, glucose. So ZP. I've said it before in many lectures, we are working on a continuous cortisol sensor. We're implanting into fish. ZP does have case studies on the internet about measuring lactate in sweat, and I know this person has seen this. I don't think we've done continuous pH sensing. We have done continuous potassium sensing, and of course we've done continuous glucose sensing. Without saying it, we've done tens of thousands of hours on continuous glucose sensing, and an 8 hour period is fine. So, these are the kind of things that they want to do. They're asking here, what's necessary to modify. Let's say you had a wristband. So let's call this the wristband. What do I do in order to modify that wristband to be specific to a specific sensor? This is a microneedle array. This has been a very expensive device to, let's say, develop. This is what makes it specific to a new analyte. So for every analyte, at the moment, it's a particular microneedle. ZP, by the way, has the technology to actually do multiple analytes on one micro needle array. In fact, we've done it for ketones and I think it's ketones, either ketones and glucose or ketones and lactate at the same time as well. I can't remember which combination. So I suppose I was going to say, this is the wristband. These are the sensors. If you want to do glucose, it's a glucose microneedle. If you want to do potassium, it's a potassium microneedle. I just backed up slightly because I realized that we actually have done a combination. But the only problem I have is that this kind of work is really expensive, and it can't really, I mean, a university setting can bring you to technology readiness level 3, but really to be able to put this on human beings, you're getting to technology readiness levels 7 and 8. It's got to be really robust. But that said, in answer to your question, this is a wristband, it's a sensor per analyte, but actually with microneedles you can do multiple analytes per sensor. And we've done a combination of 2 of them anyway. The frequency of biomarker data obtained, to be honest with you, it's just a setting in the software, so it's not a super pertinent question. Depending on the analyte, we might do it 1 per minute, we might do it 1 every 15 minutes, we might do it 1 every 60 minutes. That's just an engineering setting, so I'm going to skip it because I want to say firmware software change, but it's very easy to change that, so it's not super relevant. Can you continually monitor glucose for 8 hours? At ZP, we're very active in CGM space. In fact, I've got one here. This is the Abbott Freestyle Libre 2. This is not my product. This is Abbott's product. It's a different form factor what you're talking about, but this, for example, goes onto the body, I think, possibly 10 to 12 days. So duration of 8 hours is fine, okay? So I will I have answered that one. Can the same glucose strip be utilized for monitoring glucose level on multiple individuals? The answer to that question is no, because you will risk cross-contamination between people. Anything that's been kind of in touch or close intimacy with the body, you cannot then be lifting that up and putting it onto somebody else. Otherwise, you have to have a sterilization routine, and you're giving yourself a whole new problem of having to sterilize in situ or sterilize out in the field where it's really outside of your control. So it's really a kind of a risk assessment, which I just did a mental risk assessment that you can't do that. It's probably worth saying that, we're really talking here about development work, and these kind of projects, as I say, to get to this point is 20 million euros. So it's just worth saying how hard, how expensive it really is to do this kind of work. What is the lifespan of the wristband battery? I mean, this is a sort of small engineering comment. I think we've done it it's all about the duty cycle, but it's capable of having more than 3 days, let's say. Right, so we do have a lot of. Now, when I show these sensors, I'm not necessarily saying that we were going to end up, if we did this work for people, we wouldn't necessarily use these strips. What we would be doing is using the formulations behind these strips, whether we did it in this form factor, which I'm showing this kind of screen printed electrode there, or this form factor, which is a microneedle array, I'm not going to say it's a detail, it's an important detail, but what this slide shows is that we have all these formulations, but which one we would use is a little bit dependent on the actual final application. But again, doing wearable biosensor work is really expensive, and it really has to have a proper business case. It needs to have a company that's funded to do a startup. Now at ZP we do have a OEM platform for this, but this is something that we're really kind of doing. We're licensing into companies. it's probably worth saying that when I sort of show this material, there's 50 patents behind this. So that's why I can A, openly talk about it, and B, it gives us what's called a freedom to operate. And it also gives us an exclusivity on this kind of technology for, the lifetime of a patent is 20 years. If you're interested, we do have the sort of software to run these kind of systems. So if you've got a Android phone, you can watch this video and you can scan this QR code and it will put the app, but the app is useless to you unless you ever really have the hardware. And if you have an iOS phone, an iPhone, then there's also this app on the App Store as well. But again, it's pretty useless to you unless you have the hardware. And for every analyte or test that we do, we generate a QR code. So when you open up these apps, you kind of log in and then you have to scan a QR code to tell it what particular sensor you want to run. But this is probably relevant to this question because this person wants to know, well, how do I change what I'm going to measure at any one time? Well, the answer is there's actually a QR code that would be scanned. The smart wristband, for example, could be in contact with your phone. So this phone scans the QR code. The QR code tells the app, well, okay, in that case, the wristband is actually using a glucose sensor or potassium sensor. The wristband will monitor the analyte of interest, and the data will go back to the app, and the app will send all the data to the cloud, and the person will get the result on their phone or on the watch itself. But actually all the data is also going to the cloud, which is really important because if you're trying to monitor a group of people, maybe for their wellness because you're their employer, then you'll actually get all the raw data in the cloud as well, and that could be looked at by the wider team. So we do have a way of changing these sensors in this watch, and the watch can know what it's doing at any one time using this QR system, and the QR system already exists and is already installed on the Google Play Store and on the Google Android Store. And this is what, this is a kind of a video of what the technology looks like. This is going onto the wrist. It's not really, and then here he's just peeling off the backing, but actually what there is there's microneedles going into the skin in this particular case. If you want to do it in sweat, it doesn't change much really. It's probably worth saying that, to get to this point so far, it's been like a 20 million spend. So we are at ZP, having a number of licensees for this technology, licensees in particular applications and in particular markets. But it does have to be really well funded in order for ZP to, be involved in this. And this is kind of front end and what the back end looks like as well. So you can see it here and you can see it in the image here as well. And just out of interest, there's a whole bunch of microneedles here, and it's because these microneedles can be individually functionalized for different analytes, that therefore you can do multi-analyte work. So we are doing a licensing program. If you're interested, please contact us at ZP here. I'm going to jump slightly now into question number 2, which is a good question because question number 1 mentioned about glucose monitoring. It's not pertinent to question number 1 where you do glucose monitoring by what's called a generation 1 glucose sensor, a generation 2 glucose sensor, or a generation 3 glucose sensor. But the question has obviously kind of done their homework, and they realized that there was a lot of flurry on generation 3 glucose sensors some years ago, but has it come to market? So glucose sensors, a generation 1, for example, you have glucose reacting with glucose oxidase, you get hydrogen peroxide, and that's a generation 1 sensor. Medtronic and Dexcom are generation 1 glucose sensors. Abbott, this is the Abbott Freestyle Libre 2. I know they've got an Abbott Freestyle Libre 3. This is really a Gen 2 product, and it's using a mediator. Just as way of background, the original IP was developed by a guy called Adam Heller at the University of Texas. I mean, really in the 90s now. So this is, and it felt quite fresh when I started my career, but it was in the 90s that originally started. And then there's been some action, and I should first of all back up on the generation 2 and just say it's glucose. It reacts with the enzyme, but the enzyme then doesn't react with oxygen in order to form hydrogen peroxide. It actually reacts with the mediator, and it's the mediator that shuttles the electrons. Or in the case of Abbott, I think they've trademarked this term. They call it a wired enzyme. It's a series of osmium centers that allow the electron to kind of hop along their polymer backbone and get to the electrode. Now, Abbott would argue that it gives them a technical advantage, and then there has been a lot of work by other people I'm not sure if Low Gorton at Lund University was doing this. I'm not sure if Tony Turner has been doing this. These people have kind of touched on this over the years, but with a Gen 3, the idea is that you have glucose, and you have the enzyme, and the enzyme is directly communicating with the electrode. So so there's essentially, you don't have oxygen as the cofactor, you don't have a mediator as an artificial or synthetic cofactor. You just directly electron transfer to the electrode. And as the Inquirer says, there's been a lot of people doing work on this over the years. I'm 90% certain that there's no I'd almost want to say I'm 100% certain that there's no Gen 3 CGM on the market today. And the reason being is, I don't really think it offers much of a technical advantage. And actually, I think it kind of gives you more problems than problems it solves. So first of all, the good thing about the questioner is he's really asking, why even bother? Well, first of all, Gen 1 glucose sensors are proven to work. You've got Dexcom and you've got Medtronic, and they work. And Dexcom's a perfectly fine business. And then you've got Gen 2, which one of the arguments of Gen 2 was because we don't need oxygen. We don't suffer from oxygen limitation. And because we are not using hydrogen peroxide, we don't have to use we call it a poise potential of, let's say, 650 millivolts. We can use a poise potential of a lot less, and therefore we got a lot less interferences. So Gen 2 would argue that they're better than Gen 1 because they're not oxygen dependent, and they can use lower potential, so therefore they probably have less interferences. And then Gen 3 would kind of argue, well, we get the electron direct from the enzyme, so we've got the best of everything. The thing about Gen 3 is lots of people have worked on this. Nobody's made a good enzyme for it. And even if you do it, I'm not really sure that you're solving a problem. What you can do if you generate a Gen 3 sensor is probably have a very good IP position. This is a very litigious industry. So coming up with a CGM, you will fall foul of incumbent companies. They want to protect their markets, so you can be sued, and it's very hard for a startup. But of course, if you're working on a very different technology platform to the incumbents, then they will still attack you, but their attack is not so effective because you could immediately say, well, we're a Gen 3 sensor. So there are people who have commercially tried to make these, let's say, Gen 3 enzymes, but they've just not been very successful. And in the literature, and in talking to some of the academics who've been involved in this, the claims on Gen 3 enzymes, some people think that actually people are modifying these enzymes, but what's really happening is the cofactor inside those enzymes has become mobile. So it's not that the enzyme is so much hopping out of the electrode is hopping out of the active site and onto the electrode. There's this cofactor in the heart of the enzyme, and it's actually still mobile, and it's shuttling the electrons around. So it's really acting like a Gen 2 sensor. So Gen 3 doesn't really, I think, actually solve a real problem. The only problem it might solve is to give you some IP freedom, which is actually important. Now, Gen 2 would argue that it's better than Gen 1, but one thing I would say about this is it's never this easy. What is better depends on the whole system. So what I mean by system, it's your sensor, your electronics, your algorithms. That's the system. So if you look at Dexcom have claimed that their accuracy, their MARD, their mean average relative difference, is 8.7%. So they say that they're best on the market, cleared by FDA. So that means that they are a Gen 1. So they're meant to be the original technology and maybe not as good as Gen 2. But in fact, they claim, this is their claim, that they are superior to a Gen 2 sensor. I have not independently verified this, but that would be the claim. So it kind of shows you really that what is better is Gen 1, Gen 2, or Gen 3. There is no better. It's the entire system that makes you better, let's say. And this year, Gen 1 versus Gen 2. With Gen 3, yes, there was a lot of flurry about it. Whether any of those Gen 3 enzyme literature papers were truly Gen 3, I've had doubts cast upon it. And when you do it, if it really solves a problem, I'm not sure. The problem that it would solve, as I say, is IP freedom. What I would say is this, that as a target for a PhD, it's a good target because actually it's a hard problem to make a Gen 3 enzyme system that's robust. I think in my experience, people can do this kind of work and they can even publish a paper, but the enzyme might only last 8 hours. And in fact, you need to be lasting today, the probably market acceptance is at least 12 days and it'll be 30 days. And by the time you get to market, you may, I'm not going to say beyond 30 days because I'm thinking about if you stick something on the skin's exfoliated after 30 days, it's going to fall off anyway. But I'm getting into the detail a little bit there. But I've given you my thoughts on Gen 1, Gen 2 and Gen 3. I think Gen 3 is not a bad target for a PhD because it's a tough problem to solve and nobody's really solved it. And your biggest problem would be actually the robustness of the enzyme. So question number 1, wearable sensors fatigue. It's a good problem, but it has to be super well funded in order to do it. ZP does have this kind of technology, and we are licensing it, but we're licensing it into companies that are really, let's say, well funded. And then discussion on Gen 1 versus Gen 2 versus Gen 3. I hope I've given you a little bit of insight on this. In the end, Gen 1 and Gen 2 both work. That's been proven by the market. And the fact they're on the market. Gen 3 is an interesting academic target, and if you did it, but you have to be really quite good at probably enzyme engineering and also formulation to sort of protect that enzyme on the sensor. And the first thing you need to do is actually just test it for robustness. How long will that how long will that enzyme really last? And you've got to think that realistically you may have to get to like 30 days and stuff like that. Okay, and then just finally, thank you. You can see that we do put a lot of effort into the questions that come in. As I say, we go early because it's actually super busy, so I appreciate it's quite hard sometimes to get meetings with us, etc. But if you've got any questions, don't hesitate to contact us. Okay, thanks very much.